We have always wondered about our origin and history. For this reason, archaeologists are always searching for things that once existed in the past. A very important part of their work is to determine the age of the things that are discovered. And the way they do it is by using isotopes. So, what is an isotope? That is what we will be knowing today. We know that varying the number of electrons changes the charge of an atom, and varying the number of protons converts the atom to an atom from another element, like completely changing its identity. What if the number of neutrons is changed while keeping others the same? We will get an atom of the same element but with a different mass. Did you guess it right? And these atoms of the same element of varying masses are called isotopes. Isotopes are different versions of the same product. They may have a few special functions, but they are the same thing. One question comes to mind: is mass the only difference? The answer is no. As the mass changes, other physical properties like the density of the substance, the stability of the nucleus, radioactivity, etc. also change. But the chemical properties remain the same. Isotopes are generally written by writing the name first, then adding the mass number. For example, hydrogen has 3 isotopes, having only a proton hydrogen 1, with 1 proton and a neutron hydrogen 2. And the heaviest hydrogen 3 has 1 proton and 2 neutrons. Protium, deuterium, and tritium are the common names for these isotopes. You can see that the number of protons and the number of electrons are the same for all 3 of them. Most of the hydrogen atoms around us or in us are protium. Deuterium is rare and tritium even rarer. Isotopes are important because of their different physical properties. They can be detected and differentiated from others easily. Also, as the nuclear structure changes, isotopes of some elements show radioactivity. These isotopes have various uses. You must have heard of a term called carbon dating. It is called so because the carbon-14 isotope is used for determining the age of historical findings or even fossils. You might be surprised by the fact that scientists even determined the age of the moon as well as the Earth using the isotope potassium-40. Sometimes, they are used as a substitute in chemical reactions to determine the reaction mechanism. The isotopic notation is literally the symbol of isotopes, like atomic symbols. It is also called the nuclide symbol. You might already know that each element has a symbol of its own, e.g., Na for sodium, Fe for iron, and O for oxygen, etc. The big X is basically the atomic symbol. The mass number is written on the upper left corner, while the atomic number is written on the lower left corner. From this symbol, you will know a lot of information at a glance. You can calculate the number of neutrons from the mass number and atomic number. Also, the charge of the atom is written on the upper right corner. So, you can know the number of electrons as well. As the number of protons can change, a positive charge means fewer electrons, and a negative charge means more extra electrons. Note that both the protons and electrons have the same, but opposite charge. This way, the letter C with 13 on the upper left and 6 on the lower left means it is a carbon atom, and so it has 6 protons. Also, it has a mass number of 13. So, the number of neutrons is 13 minus 6, or 7. Moreover, it has no charge, so the number of electrons is the same as protons. How do you think the age of the sun was determined? Let us know in the comments. And don't forget to like, comment, and subscribe.